Hi everyone, this is Koray Kinik and I will be presenting my final project for deep learning class, streaming topic detection and sentiment analysis using Tensorflow and Kafka is my topic. So in this project my objective was to detect the underlying LDA-topics and the sentiments of tweets on streaming data on the fly. So my project has two parts. In part one, I built two separate models. The first model is an LDA-topic model. So this is an unsupervised learning approach. The second model I trained is a binary classifier on text data. And this is supervised learning using Tensorflow. In the second part of my project, I basically deployed these two models on streaming data. So the streaming data will be coming from Kafka. So my environment is Google Colab. And the first model looks like this. I have the sentiment 140 data from Kaggle. It's around 240 megabytes and it has around 1.6 million tweets as raw text. So I feed the entire corpus to the LDA model and training took a while. So this is again an unsupervised learning. What it does is to extract the underlying content and basically bins these tweets into the closest clusters they belong to. And I chose 8 topics arbitrarily in this training. The second model I have is the binary classifier. So we are talking about classifying a binary label. Positive or negative sentiment. So we have this labeled data from Kaggle, and I used the trick here, the bidirectional GRU. So that was my approach because in the class we saw that that was a good approach for language processing because the content is not necessarily in one direction. The overall idea must be expressed. Must be extracted. So that being said, I use also optimizer lamp. It's a quite new optimizer. I was excited to implement this in this model. So I have dropout layers and the regularizers for preventing overfit. So the second part of the project is deploying these two models. So this streaming line looks like this. The pipeline is that my streaming Kafka producer is consuming these tweets from a pool of the raw text and feeding them into a Kafka topic. And a streaming application, on the other hand of the pipeline, is consuming from these stream and applying as black box these two models. And the model one is predicting the topic. It is unsupervised, so I don't want to say predict in the sense of predicting, but it basically assigns the probabilities for each topic for that text. And in parallel, it also predicts literally the sentiment. It's a binary classifier of that text, each tweet one by one. So the deployment snapshot looks like this, and I will quickly go through the Colab notebook. But long story short, the final deployment looks like the streaming data flowing on the pipe, and we have these two functions. They have the pipeline. If you give the raw tweet, it basically does the cleaning and tokenizing and stem removing and applying the model on the clean tweet. And the second one goes for the topic as well. So next, I want to go over the highlights of this notebook, not all the details, but you can access this notebook from the references of this PowerPoint. So here is where I did the LDA topic modeling. Nothing novel, really. This is a straightforward implementation of scikit-learn LDA modeling. This took a very long time in the real training. And second model is basically the pre-processing of the texts and eventually applying the GRU TensorFlow model to train the binary classifier. And the Kafka producer looks like this. It is feeding those raw texts, 10 tweets per 1 second. and the Kafka consumer is the final point, the most downstream point of the pipeline. We have these two functions, and I limit the number of tweets to consume for convenience, but as the topics are flowing, it predicts the topic and the sentiment in parallel. So that being said, one trick I had to do is in Google Colab or Jupyter Notebooks, you can run a file using this magic file, and it pushes this to the background, and we can continue running the other cells. So the Kafka consumer was running on the background while this consumer is running. Thank you very much. And again, you can access this notebook from the link.